All right, this is section 3.1. Going back, Throwback Thursday.
Thursday.
We're recording this on Thursday,
TBT.
and hopefully you're watching this on Thursday. To exponential and logistic functions. And so we'll start off with a little exponential function. This is standard formish.
This is a standard formish of exponential, and the big trick on an exponential as opposed to anything else is where the x is located. So as long as that x is located up in the exponent part,
X is in the exponent.
You got yourself an exponential equation.
There is actually the one other thing that has to be true, right? The base has to be a number.
Oh, yes.
Okay. Yeah. The base has to be a number.
We don't want to have x to the x power. That's
right. That doesn't work.
That's awkward.
And the there has to be a variable in the exponent. So let's look through well, for one thing, if there's a number that's multiplied in front, that's going to be your initial value.
Right.
Because if you plug a 0 in,
you just get 0.
Yeah, no matter what these numbers are, if we put a 0 here, anything to the 0 power is 1,
right.
Which gives us a. So that number, if there is 1 in front, there's not always. If there's a number in front, then your initial value is that number.
Right.
If there's not a number in front, your initial value would be 1, right? Because that's what would
secretly
be in front.
Yeah, if it just says b to the x, then how many b to the x's are there?
Just 1. Okay. So example 1, are the following exponential functions? If so, state the initial value and the base. If not, explain why not.
No.
No as in you're refusing to do the problem, or that? Oh, no. It's no. X to the 8th is not.
And I refuse to do that problem any further because it is not exponential.
But it says explain why not.
Because the 8 can't be up there. If 8 and x were swappies.
Right. So there's 2 reasons, and you could put both or either, but it matters that our base is not a number. And our exponent is not a variable. Those are the 2 reasons there.
Yep.
All right, what about the next one?
Next one would be an exponential equation because you have a base that is a number and an exponent that is a variable.
Okay.
And by definition, that is an exponential function.
So what are the initial value and base?
The initial value would be a 1. There's 1 times
1 times
3
3x.
to the x.
Yeah, 1 times 3 to the x. And then
my base would be a 3.
Okay. Okay, how about...
No.
No?
No.
No. There's a lot of things that are wrong with this.
Let's just start with the fact that you have a variable for the base, and that's just no deal when you're dealing with exponentials.
Okay. And what's the other issue?
The other issue is that you got some sort of wacky square rooty situation up in the top, which is also awkward.
Yeah. So even if this was like a 5 for the base, it still wouldn't work because we can't have a random square root in the exponent.
Yeah, you could have like 3 times x in the exponent.
You could.
But
you can't have like some kind of a function happening inside of your
function. Yeah,
like you can't have sine x as your exponent.
Probably not.
No. Okay.
I don't think that would be exponential.
Yeah.
Because that would bounce around all over the place.
Right.
Right.
Okay.
Okay, good talk.